but you're again muted, Tito. You need to unmute.
Okay.
My turn?
Yes.
Okay.
No, sorry, no,
Oh.
Oscar, no, Tito.
Okay, muting.
Okay, can you see?
I can see your screen. Yes, thank you.
Okay, I want to start. Hi, my name is Tito Hinostroza. I am electronic engineer and I am a programmer too. And now I'm going to talk about my compiler, the P65PAS. Well, first of all, what is the P65PAS? Well, that's a project. I would say this is the name of the project that includes a compiler, an IDE, and several tools included in the IDE. So this is not just only a compiler. About the compiler and the IDE, they are both desktop applications, they are multi-platforms, and they are open source. So they are published in the GitHub. About technologies, both the compiler and the IDE have been created from scratch using the Object Pascal programming language, the Free Pascal compiler, and the Lazarus IDE. All of the projects have been developed in Pascal or Object Pascal. Let's talk about the compiler. The compiler is a command line program. If you want, you can execute it as a simple command line program. You can control by commands, or you can integrate on your favorite editor or IDE. So it's very easy to work with your favorite tool. It's like this program is cross-platform. You can execute in the same way at the Windows or in Linux. About the assembly support, the compiler is very complete in the assembler, like probably Turbo Pascal has been, because we can include the assembler code directly in the source code of Pascal. You can use your instructions, your opcodes, your operators, operands, labels, and data definitions, jumps, or directives. So it's like having an assembly in the Pascal editor. About some features of the compiler, I would say that it's a very fast compiler. This is a binary code executing. It's not like Python or some interpreted language. This is an application that is compiled for very fast and compiling fast too. Many operations are done in memory and don't access to the disk. About the language, I would say that the compiler handles the Pascal language and the modular 2 programming language. We can switch between language with some directive. And the code generated is quite optimized. Probably many compilers say that they generate very optimized code, but I would say that the main objective of the compiler has been created very compact code. About optimization, there are some options and techniques like extensive use of the registers. We have the constant folding, constant propagation, embedded logic, smart code generation. That means that when code are generated. Some in some cases, the code are simplified to create a code that don't is use the same value or storing the same value twice or many times. And there are some other optimization techniques. This is a simple comparison about the code generated by the P65PAS and the KICC compiler, that is very optimized compiler, and the CC 65 compiler. As we can see, we have very compact code generated in the same program with 18 instructions. About the compiler design, this is similar to some other compilers. We have the analysis, the stage, one lexical and syntactic analyzer. We have an optimization stage. Here we do many optimization techniques. We have the synthesis stage where the code generation is done, and there are some additional optimization. All of these stages work with intermediate representation, that is the abstract syntax tree, the AST. The analysis generate the AST, fill it. In optimization, we have some modification and change on the AST. In synthesis, we use the information of the AST to generate the code. Some important difference from other compilers probably is that we don't use some external assembler or some external tool. And even we don't use a linker to generate a binary, because the code generation generates directly the binary code. And some very particular of this compiler is that it's well documented, because there are probably 300 pages of documentation about the compiler that you can access from the GitHub too. So if you want to understand more about how this compiler is working, you can read it in the public site. This is a Hello World code. As we can see, very simple. I think we can show this. Okay, we have the compiler over here. As you can see, it's very fast for opening and for closing too. This program is of 8 megabytes size, so very compact. And the program doesn't need any dependencies. Here you don't need to install anything about external program. Let's see how I can do Hello World. This is a Hello World program for the Commodore 64. So if I want to change the platform, I need to change the unit. And this is a call for a function of the kernel. And I need to include the return instruction to give the pointer to the Commodore 64 system. So I can compile this. And as we can see, this is a very fast compilation time, and very compact code too. This is how we write Hello World in the compiler. So it's very, very easy. Let's talk about the IDE. The IDE, like have you seen, is very complete. We have many tools over here. We have an editor, we have the editor tabs. We have syntax highlighting. As you can see, we have several colors like modern editors. We have auto-completion. Auto-completion, we can use something like this. We have code folding. We have block highlighting. Or we can have word highlighting. We have column mode. We have multiple word change. So it's very easy to work with the IDE. About some features, we have to support for several programming languages. What does it mean? That we can define or use other language, not only Pascal, because in the settings, we have the syntax, and we have defined some language like assembler, C, or Pascal, but we can define too some other language. For example, here we have some files to define this language that you can edit. You can edit the syntax. Here we have the syntax definition, the words for highlighting, the completion. So you can create your language. You can add support for Python, Java, or any other language. You just create a file and give the control to the IDE, and you will see the language will appear here. So you can use the IDE with other language. We have some skins or team support. The compiler and the IDE can be configured for support several skins. Here, you want to change, probably you change. Or you leave in the default. And you can create your custom skin if you want. You set the colors, the text, and then you save that configuration as a theme, and you can use on the IDE. We have external tools too. We can. That means that if I want to test my code, probably I want to include an emulator like the Commodore 64 emulator, and I can call over here to see the result of the code. I am executing the code over here, as you can see, because I have set an external tool, well, many external tools for emulators, and I can assign a button of the toolbar, and then I just call the emulator from here and execute my code. So it's very easy to test the code over here. And as I use an emulator, I can use a compiler or some other external tools too. Well, I have an assembler panel too, the compiler. If I want to see the code, this is the output in assembler language. So very easy to see. if you change something external, you will see how it's changing over here. And I can do this in real time too, because I can activate complete compilation, and for example, I can detect errors in real time, or I can generate the code in real time. So you can see the output over here quickly. And some important, the program doesn't have any dependencies. You don't need to install anything. Probably you just need to copy the binary, the executable file, and that's all that you need to compile and test your programs. This is the IDE program, but the compiler is integrated in the code of the IDE. So you don't need to have the command line compiler program because the IDE includes its internal. About the tools, well, we have the syntax tree that it means that I can see exactly what is the some elements on how is the AST, because this tree is the real representation of the AST that the compiler used. So you can see over here how this is changing according to the code. You want to see, you can see some properties about some elements. You can even go to the part of the source code. You can analyze and see how is the compiler working internally. So this is very useful if you want to learn about compilers. We have a memory explorer. If I compile something like this, I can see how the memory is going to be filled, some position where the code is located in the memory map. And we have the debugger. Debugger is a very powerful tool because the code compiled can be executed over here like an emulator, and I can execute step by step and see how the register changes or the memory changes. I can even do not only step-by-step debugger, but I can execute even this in real time. So I'm executing this program in real time. We can see how the time is passing and how many cycles are being used in the CPU, because this is like a virtual CPU. Well, some questions about the compiler. What is missing? Well, this is a new project, and there are many things that are missing. There are some features not yet implemented. For example, we don't have the floating point support, and we need some more libraries or code because the compiler is a compiler for the 6502 CPU, but when I want to compile from special target like Commodore 64, I need to include a library, and I need to create a library to can use that platform. So we need to create several libraries that is missing the compiler, but it's a work in progress. Why Pascal? Many people ask me why Pascal, why not C? Well, there are some advantages of Pascal, but I think this is a very long discussion. Here we have some issues I want to show about Pascal. Like it's a high-level language, it's to learn and teach. It's a safe language, so it's very easy to work with Pascal. And it's easy to maintain and easy to learn too. What's next? Currently, the compiler has support for the 65C02, but it's not a very complete support, so we are adding some complete support. We are adding support for floating types too, and some object support too. Compiler have a design that is oriented to object in programming. So I can do something like probably object declaration methods like this. So the design of the compiler includes an object orientation. Even when I say that something like this, or when I say something like this, what I'm doing is call to a method the class. Bytes are like class, and operators are like methods that we can see in the system unit. All operations like addition, subtraction are like methods that we can call using the name or using just the operator. Well, we need to include more platforms too. Some demos. Well, let's try some code. I can show some sample code like this, probably. This is a simple screen manipulation. Some more graphic. In graphic mode. Some of picture. Some of sound. I don't know if you can hear that, but it's sounding. Well, there are many programs we can do, but these are some samples. Some conclusions that the compiler is a work in progress. We are doing many changes in the last week and months. This is a real open source project. You can see the source code, documentation, and binaries. All information is published. And the compiler is not only for a program, but we can use it for learning or teaching about compiler, because the IDE includes many tools that make easy about learning about the compilers and assembling too. Well, that's all. I don't know if you have some questions.
Good, thank you. I don't see questions in the chat. I'm also looking now on the Facebook page, but I don't see any comments or questions so far. But maybe I have some, or maybe I don't know if someone on the attendees, please, if you have questions, don't hesitate to unmute and ask. Maybe I had one in the meantime, because yeah, you call it a 6502 Pascal compiler, but then you showed the memory mapping. If we take, of course, here we are interested in Commodores, right? But if we take like the Apple II or something, if you build something, I guess the mapping, the way the memory is used is probably different. How do you handle that?
Well, the memory map is a reflex of the device, the internal device. This is a compiler for the 6502 CPU, as I said. And if we define a platform like the Commodore 64, if we see the unit, we will see some directives to define the memory map.
Oh, okay, so, well, yeah, you define it. Okay.
Define the memory map, and if we use some other unit, like probably the if we use the Commodore 128, this unit will define a different memory map.
Yeah, okay. I think that also answers the question I see Oscar has put in the comment. Will it support other devices like Apple and Nest? But then I didn't know the Nest was 6502 actually. But okay, but that answers that.
Derivative, I would say, should work.
Good. Yeah. Any other questions? Otherwise, I have one.
I was looking how it is distributed. I saw that there are some precompiled packages for Linux. Yes. So, are you recommending to use them? It's using Snap. Do you know about that, Tito?
Do you refer to use the Linux binary?
Yes, exactly. So can I use some package manager to install it, or should I build it from sources?
This is a portable program. You can build it in Linux. You can compile it from the Lazarus IDE, and you can execute. And that's a binary, just like in Windows. You just execute the binary. Don't need to install. But it's probably the best way to install. But I can create a package manager, but it's not needed. It's a simple program, common program, or in Linux, if you're using a graphic version, well, you will see the IDE like here, but in the Linux version.
Yeah, okay. I will play with that definitely. I like this live compiling, and I like this preview. As you said, it's a great way to learn about compiling.
Good, thank you. Tito, I had also a question, because you showed it as well in command line, right? And so you have options now. Usually we have, when we see new compilers popping up, and then people add some options, and then like you have the options like, I don't know, -C, -L, or -BV to be verbose, or -L to do some logging or something. And I was wondering if you have followed some kind of existing options, if you made it in the same way, so that people don't need to learn new options, or did you just create options based on I don't know, your own selection?
Well, for command line, I was using some commands of Free Pascal compiler, trying to adapt from Free Pascal if they exist. If they don't exist, I create them myself.
Okay, okay. So someone who knows already this other compiler, he can just adapt easily to this one, right?
Mhm.
Yeah. Good. Okay. I don't have any more questions. I don't see more in the chat. Let me just refresh the page on Facebook to see if someone has added anything in there. No, I don't see anything. The GitHub link that you have put there, I will put it as well on the agenda page, right? If that's okay for you, Tito, because it was not on the agenda. So I will put that there, and then of course after the meeting, when we have the recorded link on YouTube, I will also put that in. So thanks a lot, Tito. I will stop the recording now.